This will be a video about in and out boxes. A lot of people don't know what in and out boxes are, but let's see if we can show you about them today on this video, and also start off with why they're important. Well, one thing that they do right off the bat is they help us to understand how equations work in math. You know, it doesn't make any difference if the equation is a difficult one, like this might be one you can't do, but no matter what, whether it's an easy one like one you may have learned in second grade, or a difficult one that Dr. Einstein came up with a long time ago, the one thing that they have in common is that equal sign in all of these. And the equal sign is very much like a weight balance. What's on one side equals what's on the other side, and they balance right here at that point. And that's what the equal sign does in a math problem. It balances. It tells you that what's over here may not look like what's on the other side, but they're equal in value. You know, I don't know if you heard this before, but the old saying, someone might ask you, which is heavier, a pound of lead or a pound of feathers? Well, they certainly don't look the same. A pound of feathers would take up a lot more space than a pound of metal, but they are equal in weight, even though they may look very much different. So that's one thing that in and out boxes do. They teach us about equations, which is a very important thing to learn when you're young. Another thing they do, and this is something that we've been trying to stress in some of the earlier videos, is they show you the relationship, and I've used the fancy word inverse here, but it just means that addition and subtraction work together. They're sort of connected. They're the same thing, except we're looking at them from a different direction. The same is true of multiplication and division. This would make a point of that right here. Here's a simple fact family. Taking 3 plus 4, and the fact that it equals 7, switching around the addends, it still equals 7, which allows you to make a subtraction problem out of it with the answer, the addend, minus one of the the sum minus one of the addends equals the other addend. So it's important to remember that multiplication and division are really the same thing, two different sides of the same coin, as I said before. And so aren't addition and subtraction. In and out boxes sort of force us to see that relationship. Okay, well, if you've never seen one before, and they certainly are a great way to understand these important mathematical concepts, that if you get them when you're young, it'll make a lot of the math that's going to come in the future a lot easier. Okay, well, here's a situation. We have these numbers in the in, which is short for input, the numbers that were put in here, and something happened to them, and they became the numbers, the out numbers, or the output numbers. Well, what happened to them was a rule was applied. It was the same rule. Something happened to 40. We don't know yet what that is. You might be able to imagine what it is, and it made it become 2,800. The same thing happened to 5, and it became 350. Maybe one good way of trying to understand this, and many of the math books a long time ago used to have this machine called a function machine, which they tried to show how these input numbers became the output numbers. So you can imagine that you have this machine, and into the machine goes one of your numbers, and something happens to it in here, and it's up to us to discover what that is. And then after it happens, it's kind of like we don't see it, but we have to figure out, like detectives, what happens to it. Out comes the out number. Okay, here's that same in and out box that I showed you before, and we're going to apply this idea and see if we can figure out what happens inside of the box. Okay, well, let's take one of these numbers. Let's start off with a simple one, 5. And I've put this information up here as something really important to remember. The in number will become the out number only after this rule that we're trying to find is applied to it. Okay, let's see if we can figure that out. Okay, if you put in a 5 and out rolls 350, what happened to it? How did it become that? Well, can you think about what might happen? One thing for sure that happened to it is it became larger, didn't it? So that's a clue. It didn't become smaller, it became larger. And you know, when you think about the different things that you can do in math, there's really only 4 of them. You can add something to the 5 to make it become that, and that's a possibility. You can multiply the 5 by something, that might be the rule, and make it come up, that's a possibility. But look which 2 are definitely out, if we're going to be thinking about positive whole numbers, which we are right now. You couldn't subtract something from 5 and get a bigger number with positive whole numbers, and you couldn't divide 5 by the rule in here and have it come out to be larger. So we're pretty sure now that it's going to be either multiplication or addition. So which one is it? And if you think about it, it's the multiplication, and I'll show you why, because it's important that if this multiplication problem works with the 5 times 70 equals 350, it must work with this one and with all of them. It just can't work with one. It has to work with all. So to test it, let's take this other n number, the 40. Let's put it in there and do the same thing to it, multiply it by 70. Now, do you remember how to do that? 4 times 7 is the 28 part of the product, the answer. And the 0 here gave us one of the zeros in the answer, so there had to be another 0, and that was in the rule factor, and it comes out right. So we now know, because we've double-checked it, that the addition wouldn't work. The addition would work in both cases, but with the different numbers, and that's not what we're looking for. We're looking for the same number, and we found it. So now it's time to apply the rule that we know, times 70, to these other numbers and fill in these blanks. Okay, ready to try that? Let's do that. Okay, here's our situation. The in number, with the rule applied to it, becomes the out number. Well, this is a pretty easy one because it's just multiplying these 2 numbers together, which if you know the rules on the 0, bet you could do in your head. But if you don't remember, let's review it just quickly because we had this on another video. If you take the number at the beginning, which is a non-zero number, and you multiply those 2 together, you get 42. I've noticed I've highlighted the zeros in red, because whatever you have for zeros in one factor and the other factor must appear in the final answer. That's like multiplying 100 times 10 is 1,000. So remember, we just add up the zeros and it works out. So now we know that that's the out number there. Now we have an altogether different situation. We know what the rule is, but we don't know what the in number is. It's a mystery number now. A mystery number multiplied by 70 equals this product of 49,000. Well, we need to think in terms of exactly what happens. Remember those multiplication triangles when we put our hand over one of the factors down in the corner, and what happened was that we saw that we had to figure out what the multiplication was to come up with that number. Okay, hopefully that didn't go by you too quickly. Let's try another one. Let's see if we can figure out from the numbers that are given, the in number and the out number. Okay, these are complete. Let's see if we can figure out what happens to each of these in numbers to become the out number across from them. Okay, so what are you thinking? Well, first of all, we need an operation in math. Is it addition, subtraction, multiplication, division? Well, in this case, numbers are getting smaller, aren't they? In both cases, the numbers are getting smaller. Well, that narrows it down for us. It's either going to be we're going to divide something, or we're going to subtract it. And I came up with these two based on this number, right? These two numbers right here. If I divided 240 by 60, I would get 4. Proof of that is 4 times 60 equals 240. It would also work, in this case, if I subtracted 236 from 240, I would get 4. Now, you might need a piece of paper to do this out, but then again, you might not because the zeros are involved. You might be able to just do a quick estimate and say, well, there's no way that this rule is going to work here with 18,000, take away only 236 and come up with 300. Because if you took only 236, you'd have 17,000, even if you don't know exactly what the answer is. So a quick estimate and a little bit of common sense there about math tells us it can't be that one. It has to be this one. And if this whole in and out box thing works, then 18,000 divided by 60 equals 300. So, it does, and of course the check on it is the fact that the 300 times the 60 would equal 1800, because 3 times 6, there's your 18, and 1 0 to put back into the product, and 2 more, it balances out perfectly, the equation works. Okay, now you know the rule, and now you can solve all of the unknown parts of it. Remember, the in number in association with the rule makes the out number. So simply said, it is 360 divided by 60. Everything is just a clear-cut, straight division problem. And I hope you know the answer to that is 6. Just a reminder of what we're doing here. So the answer to that's going to be 6. And we can check that by multiplying 6 times 60 equals that. Remember, we always use division to find a missing factor, and the answer to a division problem is that missing factor. Okay, that one's all done for us. Okay, now this is again straight division. 60, if you divide the 4200 by 60, you end up with a number that you would multiply by 60 to get 4200. Well, let's just quickly do it out on a head. It would have to be a 7 here, times 6 equals the 42. Part of it, but there's only 1 0 to put into the product. We're going to need another 0 out here, so it's a 7 plus a 0, and that makes 70. Okay, now the difficult part of seeing the opposite happen here. We know the answer to the division problem, and we know what we divided by, but we're looking for what we started off with in the dividend. Well, the way we've been checking these over and multiplying this times the rule number to find out what the dividend was, just to make sure we were right. In each case it worked out, didn't it? 6 times 60 equaled that number, 4 times 60 equaled that number, and so forth. Wouldn't it just make sense, because math is just a series of patterns that repeat themselves over and over again. 9 times 60 will give us our missing number in this particular case, 540, because 9 times 6 is 54, and there's a 0 that is put back for the 1 0 here, and of course there's no 0 to be concerned with over here in the out number. Well, what do you think? Did you get that? Okay, here's just a reminder of, if you remember what those multiplication and division triangles looked like, this is a situation where you knew both of the numbers down in the corners. You knew both the factors, so it was you just had to multiply to find that product.